Hey everyone. So if you were gone when we talked about wave calculations, you're probably looking at this assignment going, what the world? I don't even know. So it says calculate the missing values, and you're probably like, dude, your face is a missing value. So let me show you how to do these so that you don't freak out. It's really just a glorified multiplication or division problem. So you can see that we have a couple of equations. E equals h nu and c equals nu lambda. The v looking thing is just a Greek letter, and the upside down y looking thing is just another Greek letter. The one that looks like a V stands for the frequency. The one that looks like an upside down Y is the wavelength. Now, in each of these equations, there is a value that is constant. So C is the speed of light, and it's always 3 times 10 to the 8th. And then H is the other constant, and it's always that number you see there, 6.63 times 10 to the minus 34. What that means is, as long as we know either of the other two variables, we can solve for the one that's missing. So let's take a look at how that might work. Okay, so here we have our equations and our constants, and let's snag one of these values off of our sheet. Let's use the green frequency. So it's a frequency of 5.77 times 10 to the 14th. Now, from that, we want to know two things. We want to know the wavelength, which will be the space on the left, and we want to know the energy, which will be the empty space on the right. So if we want to know the wavelength from that, then we got to find an equation that has these two things in it. So the equation that has those two things in it is this one right here. So if we solve this for wavelength, then we just need to move everything to the other side of the equation, just like you do in algebra. We're going to divide both sides by the frequency. And so the frequency here will cancel, and you'll see that the wavelength is really just equal to the speed of light divided by the frequency. And so we can take the speed of light, 3 times 10 to the 8th, and divide by our frequency, which is the number that we just took off that sheet, 5.77 times 10 to the 14th. And we're really just going to divide these two numbers, and the answer is the length of the wave in meters. Now, your calculator gets a little confused when you use powers of 10, so let's make sure we can enter this in the calculator correctly. To do 3 times 10 to the 8th, we're going to hit 3. And then we're going to do second function, which is the blue button, and then comma, which is the number above, or the button above the 7, and then 8. So you see on the calculator display, it just says 3E8. That is how the calculator writes this number. And then you're going to divide by 5.77. We'll do the same thing, second function, comma, 14. That's how it writes 5.77 times 10 to the 14th. Notice when we enter it into the calculator, we do not hit the multiply button. We do not hit the 10 button. The E up here has the times 10 baked into it, so that when you divide, it gives you an answer of 5.2 times 10 to the minus 7. Don't forget to come all the way over here to look for the power of 10. Sometimes it'll be a little baby times 10 right there. This one has an E, which means the same thing. So that's the number that we can put into our chart. So if we go back and look at that, that's going to be the number that goes right here. So we can type 5.2 times 10. And now to do a superscript, you're going to hit Control and period at the same time, and then you can put your minus 7 in there, and then Control and period again. we'll take it back to normal size text. Now, when you go to use the other equation, E equals H times nu, that says I just need to take the frequency and multiply by the constant H, and it will tell me the energy. So if we do that, and we find our starting number that we had, 5.77 times 10 to the 14th, we're just going to multiply it by H, which is always this guy. And that will give us our answer for energy in joules. It's going to be a really small number because we're talking about the energy of one individual photon of light. So it's going to be small. So just like we did before, we can enter it into our calculator. Oh, I can't pull up the other calculator. So let's do it on this one, just to break things up a little bit. You can do it if you Google calculator. A scientific calculator will come up, and the button that you're going to look for there is the EXP button. It's down at the bottom. That EXP button is the same as the EE button on these. And again, you don't have to do times or 10. So here, I will do 6.63 second function. It's still the number above, or the button above the 7, negative 34. And then we're going to multiply by 5.77. Second function, that button, and then 14. And so if you hit enter, it will tell you 3.83 times 10 to the minus 19. So that's really small because that's the energy per photon of light. So if we go find where that belongs in our table, that's going to go right here, and we can say 3.83 times 10, and then do your your control comma. Oops, that's subscript. Control period is superscript minus 19, and then control period again. Now, if you notice, all of these numbers are going to be in numerical order, like getting smaller as you go down. These in the middle will also get smaller as you go down. And then on the left, the wavelength numbers will all get bigger as you go down. So if the numbers are not in sequential order, then you know something is not quite right. So it's sort of a way for you to check and see if you're getting the right answer. So give those a shot and see what you can do. Really just multiplying and dividing. Good luck.